start recording. And I'm going to say, all right, everyone, today I'm going to teach you a little bit about antibiotic resistance. Antibiotic resistance. And you can also drag this as you see fit. So I just tapped my finger on it and I drug it across. Okay. And so this is a comic illustration of what happens with antibacterial resistance. This is just one type of antibacterial resistance transfer. This looks a lot to me like conjugation. It is one bacteria giving its DNA to another bacteria. And so then I would move on and I would say, so I'm going to teach you about 3 ways antibiotic resistance spreads between bacteria. The first is conjugation, the next is transformation, and the third is transduction. And I'm going to take you through conjugation first. So conjugation is when transposons come from the bacterial DNA or from the plasmid and get transferred to another bacteria. And so then I would get, if you tap the top image, it brings up this arrow. If you tap the bottom image, it does either your eraser or your pen stroke or anything. But if you tap this top image, it shows you the arrow. And so then I would say, here is a plasmid. This plasmid contains this blue strip of DNA. This blue strip of DNA is not actually blue in real life, but it is highlighting that this is the antibiotic resistant part of the DNA. And the DNA that is in the actual bacterial genome itself also has a segment that is antibiotic resistant right there. Before bacterial conjugation, the drug-resistant form of this gene was copied and moved into a plasmid along with other plasmids that were already floating freely that contained the antibiotic-resistant gene. Next, what happens is bacteria connect temporarily from the transposons or plasmids and can be passed from one bacterium to another. So they connect via pili and fimbriae, this little bridge right here. And one of those antibiotic-resistant plasmids, now that it is being exchanged, is sent over to this non-drug-resistant bacteria. Remember, this is a non-resistant because it is blue. And once that moves across, the DNA to become drug-resistant becomes available. And so all of a sudden, this transposon that was sent across that bridge now becomes incorporated into the bacterial DNA right here. So first it's just floating freely, and then eventually it becomes incorporated into the bacterial DNA, and that bacteria becomes antibiotic resistant. So then I would simply stop.